forward or the backward, but go forward. So if we did it that way, what would then this be over right here?
0.1.
Yeah, the delta x 0.1, right, exactly. So you're going to need a calculator to do this out, and it comes out to be negative 0.0493. It is 4 decimal places. That's correct. I know. I violated the rule of AP tests, right? So then, can someone tell me, someone different, tell me what this one's going to be? Now we're changing what?
Y, not x.
So it's going to be f of f1 comma. No, 3.1, right? Minus the same thing, right? Over what? 0.1. And what do you end up with? Yeah, negative 0.3660. Yeah, they go to 4. I don't know. It's fine. Whatever. Do those two make sense, everybody?
Yeah.
So then they ask you to do the same thing, right? But they ask you to do the same thing with different deltas, right?
Yeah.
Same, but with 0.001 deltas, right? So fx13 comes out to be negative 0.0501, and fy at 13 comes out to be, let me tell you what the decimal comes out to be, negative 0.3629. Like the straddling of the point, they kind of go forward from it. So they want to approximate 3,5 using the contour diagram. So what do you go to first? You just, where's the point, right? So you go to 3,5, which is right here, correct? Oh, I got to go further, sorry. Excuse me. Right here?
Yes.
Like that? So, and they want fx, right? So what are you keeping static? Y. So what could you do? You could go up, like, so you're keeping, I went the wrong way, didn't I? You keep y static. So maybe go from here to here, like that. So basically, it's rise over run along that line, correct? So you're going to go from 10 to 8. So that's your change in the output of the function, right? But then what are you going from here? You're going from 3 all the way to what? To 6, from 3 to 6. So you're going 6 minus 3. So what are you going to get? Negative 2/3. Does that make sense? Kind of, maybe, sort of. Okay. This is specifically as x increases. X increases. It's kind of like if it would be the equivalent of like here, you know, I'm giving you a derivative, right? And I'm saying, like what's the derivative there? It's positive, right? Because you're looking to the right. You go this way, right? You don't go left. If you go left, it's going to invert the sign.
What I'm saying is like right limit. You're fixing the y.
So does it matter if I did it from 0 to 12?
So you went
1 to the left.
You went from here to here.
Right,
you went like this. Sorry, hold on a sec. Look, so first of all, the point 32 is right there, correct?
Yeah.
So let's just take a look at this right here, fx32. What are you holding steady? What's staying constant? Y is staying constant, right? So would you characterize this as a little negative, a lot negative, or positive a little, or a greatly positive? This is a little negative because it's going down a little bit, right? What about fx12? 12 is right here. What's this one? More negative. What about fy32? fy32 is going this way, so that's a little positive. And fy12? More positive. And then you have 0, right? So what's it going to be? What's the smallest one? fx12 is less than fx32 is less than 0 is less than fy32, which is less than fy12. It's a great question. I like that one. It's a good one. Does that make sense now?
Yeah. I had everything.
You don't know any new differentiation rules at the moment, okay? What does fx mean? Tell me that again. What does this mean? What are you holding steady? This is partial derivative, but you're holding y constant, right? That's the big thing. Y is constant, right? So this thing is the same as, so if we wanted to find fx32, what are we looking at? We're going to do the partial of the function, but we're holding y steady. What is the y value? The y value is 2. So if we had, what is fx2? What's that equal to? X squared over 2 plus 1, so that's just x squared over 3. So if we actually do this derivative, we're doing the partial with respect to x of f of x2 like this. It's just x, so you're doing d dx essentially now because it's a single variable equation. What's that derivative going to be? 2/3 x times what?
No.
Times x, right. So if we want now, so this is the exact same thing. There's no 3 canceling, the 2 comes down, right? So what do we play? So this is going to be fx of 3/2 is going to be equal to what? 2/3 times what? Which is just 2. It's really easy to make simple mistakes on this. It's really, really easy. That was my apprehension there because I'm like, am I plugging in the right thing? Am I holding which one steady? So it gets a little bit more fun because you can add in kind of more funness to it. So let's add in more funness, and I like using words like funness. So you hate fun? Oh, the band isn't that bad. Come on. So on this one right here, so what essentially are you doing? You're doing everything you learned in single variable calculus, one piece at a time. So if we wanted to find all the partials with respect to x, x is the only variable. That's what you're treating this equation as. X is the only variable. So if you're going to do fx, xy, only x is the variable. You treat everything else as a constant. So James Borden, what would fx, xy be if x is the only variable? If x is the only variable, y squared is treated like a what? Constant. So what's the derivative? What's the first derivative of e to the 3x, James Borden?
Y squared.
Yep.
3x.
Yeah, exactly. What about over here? Does that make sense? Yeah. So what about this one right here? Can someone tell me what zx is going to be? Someone raise their hand. Who wants to tell me what that is? Yeah, James.
So it's
Drop the.
you have to drop the power.
Yeah.
5
Times.
and 3xy.
Yep.
2x.
Mm-hmm. Yep. But then.
Derivative inside.
Which is going to be what?
3y plus 2.
Exactly. Because, again, we are treating the only thing as a variable. X is the only variable. Everything else is a constant. You treat everything else as a constant. Everything else is a constant. Because when you take the partial derivative with respect to x, x is the only thing moving. Everything else is a constant. So what about this one right here? Anybody want to kind of tell me what I'm going to have to do? Gx, what's this one going to be? Who wants to start us off here? What rule are we going to have to use? You have to use the product rule because you have a function in terms of x times a function in terms of x. So the derivative of the first, can someone tell me what the derivative of the first is? This is the first function and this is the second. Can someone tell me what the derivative of the first is with respect to x? Ray, what is it? E to the x plus 3y. Is that correct? Do you guys agree with that? Yeah. Think of 3y as the number 7. What's the first derivative of this? E to the x plus 7. Exactly. That's the key. Yeah, I wanted you to say the 7 there. Okay, but then what do we have to multiply it by? Sine of xy. But then what do we have to add to this? The first times the derivative of the second, which is going to be what? Cosine what? Exactly, because the chain rule dictates what's going to pop out of that sine xy. The y is going to get kicked out. The challenge here is that you have to continually change perspective, because are there other directional derivatives we're interested in? Absolutely. There's actually an infinite number that we're interested in. But for now, we're only interested in 3 of them. So let's do the 2 that are most common. So for this one right here, I could ask, that is a function that has 3 inputs. So there's 3 common partial derivatives. So fx, xyz. Lucy, you want to tell me what that one is? What's fx, xyz going to be, Lucy? Over. Everything is constant, so this is constant. So this is just along for the ride, but what does it get multiplied by? 2x. That's it. Exactly. What about fy, Tori? What's fy going to be?
The x is constant.
All of it's constant, so except for the y. So it's going to be what? Remember, y is the only variable. Treat everything else like a constant. So what's it going to be? X what? What's the derivative of 4y cubed in terms of y? What? 12y squared. Okay, but instead of 4, what do we have? So what's that derivative in terms of y going to be? What's on the bottom? So it's x squared z, but what comes from it? 3y what? Exactly. You're changing what's constant. So what's the third one we could do? F of fz, x, y, z. On this one, the only thing you're keeping constant is what? Z. The only thing you're keeping constant is z. So that's going to be x squared y cubed times the derivative of z to the negative 1, which is what?
No, it's either negative 2.
Negative
Z to the
z to the negative 2. That's what it would be. The challenge is always remembering, say it in your head, say it out loud, what you are keeping constant. I can guarantee you're going to mess this up. It just takes practice. It's not particularly hard, but your mind has been really hardwired to think x is changing, y is changing, z is changing. Well, not all at the same time. Yet, at least. Not yet. We'll go in directions where they will be changing, but right now we're fixing x. We're fixing everything besides one of them. We're fixing everything besides one of them. Does that kind of make sense? Okay. So for number 7 for fx, so what do we have here? fxy is equal to ln of x to the 0.6, y to the 0.4. Nice. So fx, you treat everything besides x as a constant. So what's the derivative of natural log? 1 over x to the 0.6, y to the 0.4, right? Times the derivative of the inside, right? It's a constant. You're treating y as a constant, so what's it going to be? Y. Sorry, I gotta. Well, is it okay if I put that first?
Oh yeah.
It's this times what?
0.6.
0.6 what? Negative 0. What?
4.
Right. That's good. Something cancel.
Y.
That's kind of cool. And then, can you still do a little bit more?
Yes, it's
This is pretty cool.
6 over x.
Yeah, well, it's going to be x to the negative 0.4 over x to the 0.6, right?
Which is 0 to the negative 1.
X to the negative 1, right? That,
0 to the negative 1 is undefined.
oh, and what's left? I'm sorry, you're right. So what's left here? I'm sorry, yes. There's also the 0.6. So what's left on top?
5.6.
That's pretty cool.
Yeah.
I don't know. Where did y go? It canceled. Because look, you have to drop it down here to go to the denominator when you do the derivative. But then you have to do the derivative in terms of x of that, right? So it has to be in front. Like that's the first part of it, right? But then you have to do the derivative because you're doing the chain rule of this inside, which is going to be y to the 0.4 times the derivative in terms of x of this, which is 0.6 x. That's a really good one. I like that. Cool.
Oh, so